balloon. A spherical balloon is being inflated, so the volume is increasing at a rate of, it's increasing, so it's going to be dV over dt. It also is meters cubed per minute, so we know it's cubed per minute, which is V and T. So 8 meters cubed per minute. How fast is the radius of the balloon increasing? So they want dr dt. And it's increasing, so it's going to be positive. It's RT, so it's going to be meters per minute. We know our answer needs to be in meters per minute. The diameter is 2, so the radius is 1. Volume of a sphere is 4 over 3 pi r cubed. These are always nice because spheres only have just the radius, right? Whereas cones have radius and height. So that's where you have to do that extra work with cones. But spheres only have one variable, so that's great. So, do the derivative. Derivative of volume is 1 dV over dt equals, drop the 3 in front, 4 over 3 pi r squared dr dt. Now we use power rule because this is literally like 2r cubed, right? Except it's just ugly looking, 4 over 3 pi. But that's just like a number. So all you do is you take your exponent, drop it in front with this number, and then drop it by 1, right? If you wanted to treat this as an f and a g and do power rule, you could, or product rule, you could. But then if you treat this like it's going to go away, you're treating it like an f, you'd have to do power rule or product rule, which is terrible. Don't do that. Do power rule. Drop the 3 in front. These cancel, and you're left with dV over dt equals 4 pi r squared dr dt. Now we know we're good because we're only missing one thing, right? If we're missing more than one thing, we have to go back, try again. So we get 8 meters cubed per minute equals 4 pi 1 meter squared dr dt. If you're someone who just puts the units at the end, don't. You need to do them along the way, and you need to cancel them off. If you don't, you will lose marks. Your prof will make you lose marks because you're not actually proving that you actually know how to convert and get rid of the units. You just know how to write the units at the bottom because you know this is meters per minute. Okay? You need to be able to go through and actually show me why they cancel and how they cancel. You can't just write it at the end. So, 8 meters cubed per minute equals 4 pi meters squared dr dt. You get 8 meters cubed per minute divided by 4 pi meters squared dr dt. So you're going to multiply by 1 over 4 pi meters squared dr dt equals dr dt. And then the meter squared cancels off 2 of those. The 4 and the 8 cancel, you're left with a 2. And on the top, you're left with 2 meters times 1, so 2 meters over pi minutes, which looks a little weird. So you can write this fraction out front, 2 divided by pi meters per minute. Right? Try this one. So the surface area is 4 pi r squared. What does it give us? A snowball melts. So they don't have to say decrease. If they say melts, they're telling you it's decreasing, right? So the surface area decreases at a rate of 0.5 centimeters squared per minute. So surface area, so d surface area over dt. If you did just s, if you did just a, that's fine. 0.5 centimeters squared per minute. But it's minus, right? It's minus because it's decreasing. It's negative because it's decreasing. Find the rate at which the radius is decreasing, so dr over dt. If you forget to make this negative, this won't become negative. And you can't just put a little negative at the end and say, oh crap, it should have been decreasing. I will see that, and I will take marks off. Because you're not proving that it's actually decreasing. You're just proving that you read the question and you know it should be decreasing. Okay? Find the rate at which the radius decreases when the radius is 4 centimeters. So, the derivative of surface area is dSA over dt equals 2 times 4, which is 8 pi r dr dt. This is negative 0.5 centimeters squared per minute equals 8 pi 4 centimeters dr dt. You do not need a calculator for negative 0.5. 0.5 is a half. You know that. Turn it to a half. So you're going to get negative 1/2 centimeters squared per minute equals 32 pi centimeters dr dt. Divide by 32 pi centimeters. Equals dr dt. You're technically dividing them both by 32. Okay, so you're going to get negative 1/2 centimeters squared per minute times 1 over 32 pi centimeters. The centimeters and the centimeters squared cancel. Left negative 1 times 1, which is negative 1. Centimeters on the top. 2 times 32 pi is just 64 pi. Minutes on the bottom. So negative 1 over 64 pi centimeters per minute. Yeah, because it's when I canceled these off, the centimeters stayed. So it shows us that it's going down, right? And it showed us through the whole thing that it's negative, that it's decreasing. Okay? Not just, oh crap, it should be decreasing, put a negative at the very end. All right. We have the side length of an equilateral triangle decreases at the rate of 2 centimeters. So we know that ds over dt equals negative 2 centimeters per second. We want dA over dt, right? Because they want to know the area decreasing. They give us the area. Now, people, think about this. If I do the derivative of area, correct? The a just goes away and becomes a 1, correct? So why would this be helpful? Why would they give me this if it's just going to go away? Because I'm going to need this in order to be able to actually do the derivative. So we know an equilateral triangle looks like this, right? So your base is the same length as your side lengths, correct? But we don't know our height. We agree? So remember with a cone, when we had to get rid of the r or the h, we just did a ratio because we could? You can only do that with cones. With anything else, if you're missing it, they'll give you the actual area or whatever, and you'll fill that in. You'll fill in x, you'll fill in h, and then if you solve for h, you can just plug it in for the h. So let's do it this way. You're going to do area equals base height divided by 2, or 1/2 base height. It's the same thing. So area is 100 equals base, which I'm calling x, height, which I'm calling height, and 2. Now, if I solve for h, I can plug this in for the h, and it gets rid of the h variable and replaces the h variable with an x. Then I'll only have x's, and then I can just do normal math. Because this question up here told me nothing about height. It didn't give me the height. It didn't give me what the height is decreasing or increasing by. So I need to get rid of it because I actually don't have anything to fill it in. So if I do the derivative of it, I'm not going to know either of those values, and they're going to stay. And the only way I can solve for something is if I'm only missing one value. Well, there I'd be missing 3. Yeah? 1/2 base times height. So you'll bring the 2. So it's 200 equals x h, and then you just divide by the x. Oops. So h equals 200 divided by x. So then when I use my formula, area equals pi, oh, whoa, I'm going into different forms. I can substitute that in for h now. For b, I'm going to substitute in x, and a, I'm not going to substitute anything in for it, right? So a equals x, 200 over x. Why did the x's cancel? No, the x shouldn't cancel. Go away.